And welcome back to 3.1 podcast. In the last podcast, we were dealing with significant figures and expressing accuracy appropriately. And in this podcast, we want to take a look at rounding measurements and expressing them again in scientific notation, and then doing some calculations. So, in this first portion, this is still part of the optional piece, but just bear with us a second, because in the last part of this podcast, when we go over example number 5, this is something that you're going to need to be able to do. It's just changing something into scientific notation once again. But in example number 4 here, it's asking us to round the measurements in example number 3 to 2 sig figs. Okay? So if we go with letter A, if you recall, the 0 is not significant, but the 1 and the 2 are significant. And so you want to keep those, and you want to use the next digit, which happens to be the 3, to determine how you're going to round up. And you're going to be using your normal rounding rules that you learned probably back in elementary school, where if you have a 5 or larger, you're going to round the next digit up. If it's a 4 or below, you're going to keep that last digit the same. And so in this case, you have a 3, which is a 4 or below, so this 2 will remain a 2, and this number will be 1,200 meters, and that is to 2 sig figs. How do you know it's to 2 sig figs? Well, using your Atlantic Pacific rule, you're going to skip over the decimals absent. You start on the Atlantic side, skip over the zeros, and we have 1, 2, and so that is now to 2 sig figs, 1,200 without a decimal. Letter B, we have these 2 zeros being not significant, but the 5, the 7, the 3, and the 0 are. So we want to keep the 5 and the 7, and then look to the 3 to see if we're going to round this up. The 3 is going to keep this 7 a 7, and so we're going to have 0.057 meters as our measurement. Again, starting on the Pacific side, if you want to double check yourself, you start on the Pacific side, skip over zeros, 1, 2 significant figures, and so we have now rounded to 2 sig figs appropriately. Letter C. All of these digits were significant, so we are going to have the 8 and the 7, and now the 5 is going to tell us to round the 7 up to an 8. So the correct number here should be 8.8 times 10 to the negative 2 grams. Again, both of these numbers will be significant, so there's our 2 sig figs. And finally, in this last number, letter D, we have all of these non-zero numbers are significant, but we only want the 1 and the 2. The 6 will make this 2 round up, so we're going to be left with 1,300,000 milliliters. 1,300,000 milliliters would be the correct number. Now, when you round, the final number should approximately be the same number that you started with. You don't want to round this to 13 and say, well, we got 2 digits, so that's all we have. Well, no, because if you're starting with 1,267,400 and now you're rounding to only 13, that doesn't make sense. This number here rounds to this number here. This is not correct. Right there. Okay, so you should be able to round to the appropriate number sig figs. In AP Chemistry, for those who go on to that, all of your answers must be expressed to the appropriate number of sig figs. And now in number 5, we want to write these numbers out in scientific notation. All right, so let's go ahead and do that. 1,200, you want the decimal after the first non-zero number, so we have 1.2 times 10 to the, well, if you put the decimal here, 1, 2, 3 spaces to the right, we'll move it back to where it should be. So that's going to be 1.2 times 10 to the third meters. In letter B, we have 5.7. And by the way, as I'm going through this, feel free to pause and try these on your own before I ever go through the calculation and see if you can't do it. So for letter B, we want the decimal actually between the 5 and the 7. So we're going to have 5.7 times 10 to the, well, if we put the decimal here, but the decimal belongs there, we need to move it 1, 2 spaces to the left, so that'll be times 10 to the negative 2 meters. Letter C is already in standard scientific notation, so we're good there. I'll just put a check by it. And in the last one, we want the decimal between the 1 and the 3, so it's going to be 1.3 times 10 to the, well, if we put the decimal right here, the decimal, even though it's absent, belongs right there. We're going to need to move this 1, 2, 3, 4, 5, 6 spaces to the right, so it's 1.3 times 10 to the 6th milliliters. Now, how do you know how many digits to carry in your number here? Well, if this number has only 2 sig figs, this number here should only have 2 sig figs. You don't want to write 1.300000 times 10 to the 6th because that's expressing more accuracy than the number actually has. So you don't want to do that. You want to keep the same number of sig figs. All right? Okay, we're going to go ahead and pause it right here, and we'll pick this thing up with the calculations with sig figs. That is an optional portion, so if you're not doing the extra credit in this particular chapter, you're going to be done with 3.1. For everybody else, we'll do this in one more podcast.